Welcome back, team. We are again here in the first part. We have covered the cable sizings. So there are three fundamental things which have to consider for a cable sizing. First is the physical parameter, in which physical conditions, physical orientation we are laying the cable, and second part is the short circuit current withstand capability. Okay, so for particular short circuit current, which kind of the cable is able to withstand in this condition or not, and third is the voltage drop criteria. Further, in this today's section we will extend the part 1 in covering into the part 2. Basically in this session we will deeply dwell yourself into the some IS code standards and some real life project scenario. So just starting the some IS code standards which I have to show you. So coming to the pictures, yeah, guys, this is the IS code that equals to 3169 part 6, and basically this is the for XLPE cables and the PVC cables, and what is the current and what is the derating factors we have to consider. So we will discuss all the things in detail. Yeah, okay. So some basic component that key that is mentioned, that is the maximum conductor 9 conductor temperature 90 degree, thermal resistivity, ground temperature that equals to standard temperature we consider 30 degrees Celsius, and the ambient air temperature that equals to 40 degrees Celsius, and the depth of the laying is considered 750 okay. So basically, this IS code explain the things how to install the cables behind the technical teach. For the installation manual, there is the IS 1255 separately for the installation purpose, but this is crucial for the designing part. Okay. So when we talk the designing, so there is considered three categories. If the cable is directly buried under the ground, that is the case one, and it can be air buried. On basically the outdoor, the cables are laid outdoor in the air, and third in the duct, in the case of the duct. So that in the case of the duct there is no heat transformer, basically that's the kind of the tunnels you can mention. Okay, or some highly space constrained areas where we use. Okay, so that's the things. The table 1 that is mentioning the current rating AC for two single core cables with XLP insulations. I just check I'm able to run my pen here or not. Guys, I'm sorry I'm not able to write my notepad here. But from the cursor I will explain you what the meaning of these things. Okay. So this is the for two single core cables with XLP insulations and rated voltage is 1100 voltage. So first things we have to consider, if your application is less than 1.1 kV, then we can refer this tables. And for what kind of a cable? Two single core cable. There are two and single core cable. Okay, one plus and one minus. Okay, positive or neutral or positive or negative. So for 1.5 SQM cables and the cable is copper, then it will carry 32 amps, and if it's aluminium it will carry 26 amp. Okay, this is the case of where the cables are directly buried under the ground. If there is single way duct, okay, so in the copper 27 and the aluminium 22. If you see the comparison, guys, okay, so what is happening here? In the single way there is heating is not dissipated to the environment, but the in underground it is possible to dissipation of the heat to the moisture of the air, or if there is a dry air, so that can be dissipated, but the air, that's the kind of the adiabatic, because the air is insulation of the cables, and in the duct the heat is not transferred from the outside of the ducts. That's the derating is there. Okay, and for this purpose, okay, in air that's the 22 and also sorry 28 and 22. So air is also the derating is there. If I go for a little bit lower side for 300 SQMM, yeah, 300 SQMM, if you see the cables, okay, that equals to in the ground 556, sorry, 576, 454. This is reduced in the single way ducts, and this is also reduced in the 369. But if you see in the air, that equals to 700, that's the greater than to the ground buried. So these can, this kind of the combination is derived by the IS standards, keeping the basic, keeping the concept of the heat transfer and the heat generated during the flow of the electricity. Okay guys, hope you understand. So there are multiple tables, okay, that equals to three single core cables. Okay, there are three cables but they are single core. Okay, so what will be the data you can mention here, and this typical table is mentioned for the two core cables. There are two core cables with XLP insulator and rated voltage 200. That means if I try to mention what is the meaning of two core and one single core cables, let's come to that PPT. Okay, suppose that there is cable 1 and this is the cable 2. So this is the basically two single core cable. Okay, 1C cable, single core cables. But if you see like this is the one cable and this is the one cable, and these are the insulated by the kind of the PVC material. There are some filler. So this is called two core cables. Okay, if there are three cables like this and they are covered with the outer PVC sheet and some filler materials are filled here, some armoring is there, so that is the part of the cable construction. We will not discuss these things here. Okay, so this is known as the three core cables. Okay, if there are cable 1, cable 2, cable 3, these are the separate cable, then we will call it three single core cable. Hope guys you understand the concept, what the meaning of these things. Okay, coming back to the IS standard. Yeah, so guys, you can refer and you can ask the same IS code standard from the comment box. I will provide to you. Just drop your mail ID. Okay. So for the voltage level, I have to check. Yeah. Yeah. Concept of the thermal resistivity is there. Okay. Let me check from where is, yeah. Yeah. Depth of the buried grounds. That's also matter. We consider ये 11 kV voltage है ना. So there is the factor that is associated with the ambient air temperature. Okay, if my ambient temperature is defined under 40 degrees Celsius, when in the reference of the this IS code, there is mentioned that the ambient temperature is considered 40 degree and the ground temperature is considered 30 degrees Celsius. Okay, so the factor is considered 1 for the 40 degree ambient air temperature, ground के लिए 1. If you go for the higher side of the temperature, the factor is greater. I think this is a little bit blur, and for upper side it is the factor of the 1 point something. Similarly, if the temperature derating but temperature is lower side, it's the positive side of the cable. Okay, so what is the application of this? For example, if I laying a project in the Leh Ladakh where the temperature is below the 45 degrees Celsius, it may be below the 25 20 and it may be the 5 degrees Celsius. So we have a positive margin in the cable sizing. But same the project is designing in the desert of the Rajasthan, that equals to uh, western part of the Rajasthan. Okay, so there we have to consider a temperature that equals to ambient temperature go 50 degree, and it may be the 51 degree. Accordingly, we have to consider the margin. So in the case of the higher temperature side, there is a negative margin, there is a loss of the margin. But in the there is the temperature is a lower side, there is the positive margin coming in the picture. Right? Hope you understand my points. Let's move to the second part. Okay, ground temperatures we have mentioned. Now coming in the picture, depth of the lay. Okay, so the in the starting there is mentioned the depth of the laying is considered 750. There is a reference of 1 is considered. If we go to the increasing the depth, so the factor of the margin will be reduced. The efficacy of the system will be reduced. Okay, that's clear for 750. Okay, hope you are able to understand what I'm trying to say. If you have any queries, you can mention the same in the chat box. Okay, then soil thermal resistivity is the again things. So this soil thermal resistivity of the soil, basically these data is achieved during the geotechnical investigation of the land or the locations we are here to installing a project. Okay, so that's generally we consider 1 for the values of the thermal resistivity, and corresponding there is a factor for 1.5, there is the factor of 1. If we go for the higher thermal resistivity, okay, so basically there is the margin of negative, and if there is the lower side of the thermal resistivity, there is the margin of the positive of the things. Okay, just try to understand what is the meaning of the soil resistivity. Soil thermal resistivity, that means the soil is capable to the transfer of the heat or not. In the heat transfer of the soil, there is some kind of the resistance coming in the picture, that is known as the soil thermal resistivity. Okay, let's start with little bit examples. I coming into PPT section. Okay, guys, yeah, where is me? Okay, just clicking pen. Suppose that this is the soil 1 and this is the soil 2 and this is the soil 3. This is the 3 project specific location. If the in the geotechnical investigation this value come 1.5, 1.2 and 1.8 like this. Okay, so this IS code is designed for 1.5. If there is 1.5, so there is this less soil resistivity, that means my heat is dissipate early. There is no barrier, यानी कि lower side of the barrier for the transfer of the heat that is generated in the cable due to the power flow, right? And if there is the soil thermal resistance 1.8, what of meaning of this? There is the higher side of the soil thermal resistivity. Okay, if there is higher side of the some thermal soil resistivity, that means there is the more barrier to the transfer of the heat that is generated in the cable due to the flow of the power. Of guys, you understand my points why these derating factors comes in the picture. Okay, let's move to the IS code. Yeah, so this is the concluded things you can wrap up. If you go through this IS code, you will get lot of things. Whenever I go for this IS code, I definitely learn something new every time. It's my own experience. Okay, and one more factor we have to consider, how we are grouping the cable. And yeah, so this is the grouping natures. What meaning of these things of the grouping of cables? Okay, we will explain in the PPT part. Okay, let's move. Okay, so suppose that there is single cable. Oh, what I have to consider. This is the single cable. This is the 2 cable. This is the 3 cable. And this is the 4 cable. Okay. Suppose that this is laid in the depth, uh, ground, whatever the conditions you are mentioned, this is ground. So basically the factor is that one cable, so heat, the lossage are coming due to the only one cable. there are two cables, there is the more heat generation, more lossage. Okay, three cables, more heat generated because there are the more lossage. Okay, so basically heat is generating on the higher side if you are affecting, if we are laying the more cables. Okay, second thing, suppose this is the one combinations, we are touching the cables like flat touching. One is the trefoil arrangement. Okay, and second thing, that is the trefoil arrangement, but at a distance, a minimum distance we are keeping d, and in this case some kind of the minimum distance we are putting the d, so this distance is calculated center to center. Okay, so what its difference in the every case, since this is the flat touching, so heat is generated here and heat is also generated here, but there is some kind of the space, okay, जहाँ पे उसकी heat dissipate हो जाएगी, but here more effect are coming to the heat. The kind of the concentration, yeah, here is the higher side of the concentration of the heat, here is the heat also, but there is a lower side of the concentration. Similarly, if there is the distance in the trefoil arrangements, so obviously the low kind of the concentration is there. So if we are laying the multiple runs, we have to consider derating factors. Okay, quite clear? Any doubts, team? If you have, you can put on chat. Right. Second thing is the trefoil arrangement. The reason behind the trefoil arrangement is basically in the AC cables, or the regions that these cables are in the close proximity. Oh, I have a call. I have to pick that call. Just hold for 2 seconds. Sorry guys for interruptions. I have a one call I will receive little bit later. Okay, so where was we here? Okay, we try to understand the why the factor of the grouping is considered. So same is mentioned in this IS code what we have to consider if one cable and one number of trays. So there is a grouping factor. If we are laying the numbers, so the grouping factor is reducing the margin. Okay, how you understand what is the phenomena? This is basically for the low voltage cables, and 3961 IS code that equals to basically for cross-linked polyethylene thermoplastic. Okay, so this is basically the, yeah, some reference is taken, and maximum conductor temperatures, thermal resistivity of the soil, 30-degree ground temperatures, these are the commons, and the data is different, we have to check like, okay, yeah, these value, so similarly same way, nothing different. Okay, so we this data we take as the masters. Okay, when the cable sizings. Okay, coming to the real life example team. So this is the basically a projects for a 300 megawatt power plants. Okay, and these cables are going from the inverter control room to the main control rooms. Okay, this is the design part. Okay, so here we will define some systems. Okay, if I able to run my pen, I will not able to run my pen here. I will see how can I my cursor here, but if I go enable editing, okay, sorry, we could not find your data. Okay, this is the password protected. Okay, I will check this. Okay, team, so what is the my things, the system voltage is equal to 33 kV, and the frequency of the system equals to 50 hertz. Okay, and what is the ground temperature is considered 40 degrees Celsius. Depth of the laying is considered 1.05. So there is a derating because we are going to the lower side. And what derating it mentions, we have to check the IS code. Okay, if what is standard consider? Okay, just checking. Yeah. Okay, so for 3360 11 kV cables 900, mm is the reference. For 22 and 33 cables 1050. The system is designed at 1050 because there is no derating for the temperature. If I designing for the LB, so I definitely go for 950. Okay, group laying of the cable in the ground in trefoil formations. Okay, we are forming the trefoil. So there, the trefoil circuit will 200 spacing from each circuit. Okay, so that is considered 0.73. Ground temperature 0.91, because ground temperature is considered 30-degree reference, so there is a derating of the 0.91 after the derating. Okay, thermal resistivity of the soil. Okay, this is the 1.5 semi per watt. The bale, sorry, 1.5 meter. Here is the semi, so centimeter. So we multiply that 100. So if I check the overall derating factor, that is the product of all these things, that equals to 0.666. 6643. Okay, what is the meaning of this? If a cable is carried to the 100 amperes for this environmental conditions, that cable only able to withstand the 66 amps. Okay, this is the loss of the capability of the cable. So we have to optimize this derating. We have to optimize this derating. This is the concept. The first part we mentions what is the derating factor due to the physical condition and physical laying conditions. This is one. Now coming to the second part, that is basically the short circuit calculation. T. So how the short circuit is calculated? There is the one formula, IS equals to Ka by root T. So we have to calculate the area. So ISC equals to, if I come to the ISC equals to Ka by root T. Okay. How the K is calculated, that is the second part. We will discuss in separate video. Okay. Just remember ISC. So we know the short circuit current. So area equals to ISC root T by K. K की value different होती है for aluminium and for copper cable. Got it? Coming back to the Excel. Okay. So ISC into root T by K. ISC is short circuit current in the system. This is the 33 kV system, and for the 33 kV system, the short circuit current is the 25 kiloampere by default. But when we have the higher level of the system for 220 kV and 400 kV system, and we come on the downstream, so the short circuit current is calculated on the considering the impedance of the power trafo, inverter duty transformer, all these things, and by after calculating these things, the short circuit value comes 14.5. Got it? T, the maximum disconnection time in the second, that is considered 0.5. Okay, this is basically design in the relay coordination and the production philosophy key, for which times my cable is able to withstand the short circuit. Okay, so that is derived from here. Okay, generally we consider 1 amps. Okay, because the 33 kV breaker also have 3 seconds, but the system level have the 0.1. Okay, and my system's battery is a little bit low. We will consider. Okay, just finish this. The values of the K are considered K equals to 0.143 for copper cables and K equals to 143. Okay, so this value is calculated. This is the formulated value. Okay, now coming to the third thing, that equals to voltage drop criteria. What is the voltage drop criteria? We have to consider, because there is some kind of the power is flowing. Okay, since the cable have some kind of the resistance, so there is some kind of the power loss. Okay, how? Just example with the PPT. Okay, this is my conductor team. This is my conductor. Okay, the power is flowing from A to B, and this is the some definite length cable. Okay, so some resistance obviously there, And if the power is flowing in the AC system, there is some kind of the resistance plus some reactance value. So sorry, R plus Jx. These value have. So basically, if here is the V1, due to the some losses, there is the V2, and there is the some delta V. V2 equals to V1 plus delta V. Due to this delta V, some power is flowing from here to here, basically flow of the electron. So there is some kind of the loss that is defined by equals to I square R plus Jx, or V square by R FB into I power. That's the three formula on the basis of which we are able to calculate these things. Okay. So team, on the basis of this, there is the delta V criteria, voltage drop. So for the distribution system, voltage drop should be less than 5%. Okay, less than 5% for the whole system. So the value we are considering here will be power loss, and this, since one thing I will add, we are designing this AC system, so there are three phases. So the power loss is 3I square RL. Okay, power loss. Okay, so coming to the calculations part. Okay, the first cable that is running from the ICR1 to the main control room buildings, that equals to cable type XLPE. Okay, cable length, what is the length of the cable? 2340 meter. Okay, and connected load in the kilowatt, that equals to 13.2 kilowatt system. Okay, power factor, that equals to solar power plants, so that the unity power factors. If there is another kind of the power factors, we have to consider 0.95, 0.9, 0.8 as per the system requirement. Okay, so load amps, what is the load amps, how it is calculated? Okay, I, that equals to basically currents. Okay, why this is required? This current is required to define the total ampacity we have to carry. Just coming to the PPT. Okay, what this video may be definitely really long. Okay, so what power we have to carry? Basically the current we have to carry, and this current is carried by the cables. And for deciding these cables, we are deciding the runs, how many runs, and what is the SQM we have to carry. This is the all purpose. Okay, so we have to first decide how much amount of the current we have to flow. So how it is defined? This is the formula, that equals to kVA rating of the system. It's calculate root 3 VPA, V line I line cos phi. If I write it again, root 3 of V line I line cos phi. So kVA equals to 13.2 MVA. What is the line voltage? 33 kV. And if I have to consider this, so I have to kVA and 13 to, okay, into root 3 into I line cos phi. Cos phi हो गया यूनिटी, कैंसिल आउट, 33 kV डिवाइड बाय रूट 3. KVA से KVA कैंसिल आउट हो गया, एम्स कितना निकल गया बाबू? रूट 3 into 33. So team, we are able to calculate what is the amps we have to carry. So in the Excel, the same value is calculating. How? F15. What is the F15 value? This is the 15, and F15 value is this. What is that kVA? 13.200 kilowatt. Why this kilowatt mention? Because that is the unity power factor. Okay, so into root 3 C4 into, yeah, C4, this is the C4, the system voltage, and G15, power factor. Okay, so what we have to carry the load amps, that equals to 231 amps. Okay, the first things we have to define the what a kind of the conductor we are using, that equals to 1C, we use 3C. Okay, so there is option when we this data is designed. Okay, now the cable size we have to select 300 SQM of cable. From where this data is calculating, this data is calculating somewhere else, that's the minimum cross section area of the cable is required. Okay, we have calculated this value somewhere. How I will know? Now the question is rising ki why you are selecting the Boss 300 SQM cable. So basically that is calculated basis of this formula, that equals to minimum SQM. Okay, and the value is somewhere here. Okay, k by root t, that should be somewhere. Okay, okay. We have to calculate the manually. ISC equals to k by root 2, what the minimum value is coming in the pictures. Okay, okay. I was, if I consider k 0.143, ISC equals to 14.4 and root 2 equals to 0.5 root t. If you put these values, we are able to calculate the minimum SQM. Okay, just I opening the Excel. Hmm, calculator issue. Just calculating. What was my values? Yeah, values 14.4 divided by 0.143. What the value are coming, that equals to 100 point something, 100.699. Okay, okay. Now we have to multiply this into, okay, into, no, clear, 0.5 into, yeah, into 100. Yeah, so that's the minimum SQM are coming in the picture. Some data may be error. Yeah, That's value for the copper cable. We have some calculation mistakes. Multiply by this 14.4. That's the kilo ampere, na? Okay, kilo ampere. We have to 4 divided by, yes, 0.094. Point 4. What's the value are coming? 153 into 0.5 root 108 SQM are coming in the picture. Okay, and we are selecting the cable for the 300 SQM. The purpose for this is, yeah, the value are put here, na? We are not. The cable size required on ISC criteria. ISC equals to K by root 2, 108. So 109, after the round off, this value are coming 109, and we are able to calculate 1.108. We are in the formula, if you are able to see 108 something. Okay, so this problem are the sort out. Okay, team. Okay, so this equals to minimum. We have to choose the cable higher on this. So first things, if you are choosing the lower SQM, there is the current rating is the lower side. If you are choosing the higher SQM, that will be the higher side of the cable rating. So we are optimizing these things, and we are achieving the 300 SQM cable. Okay, guys, and details of the cable 19/33 kV. What is the meaning of 19/33? This is the homework for you. And method of the laying ground. So there is the derating for the ground is considered 0.91 on 40 degrees Celsius, and group laying factor equals to 0.73. Okay, so derating was achieved this, and derated amperes, this cable were able to carry the derated amperes. So coming in the pictures, this is the formula based things. Okay, so this multiply the 300 SQM cables, and so this divided by this. Okay, derated 235. So number of runs required 0.97. That means we have to round off 1 runs. Okay, then VA by VA, voltage per amps kilometer. Voltage per amps, what is defined by voltage per amps? Voltage per amps is defined by the impedance of the system in the AC system, and per kilometers, because we are running the cables in kilometers, that's why we are considered this. You can by multiplying this to the 1000, you can convert this to the per meter, so that's not the issue. Now VD, what is the voltage drop? That equals to 161.2. What is the voltage drop percentage? 0.489. Okay, 33 kV system पे 0.489, that's the voltage drop. Okay, resistance of the load, temperatures, reactance, and the power loss. Okay, that's the power loss is defined as the 0.369. Okay, 0.369. Okay, so what you are considering the things, if your cable length is the lower side, your losses will be higher sides. Okay, for the system efficiency, when we calculate the system efficiency, length is the crucials. Okay, okay, one things we can go the higher SQM for they reduce the power losses, but there will be a limit of these things. Okay, so team, by discussing this video, this session, you are able to compete yourself for the cable sizings. Okay, if you go through the part 1 and the part 2, you will not have a single doubt for the cable sizings. Parallelly, there are some kind of doubts definitely came in the pictures, and by working these things, you will excel your skills, and you can get it mastery on your skills. So hope guys you enjoy this video. And definitely I would not request you. It's a kind of the win-win situation for both of us. If you want such kind of the future videos, don't forget to like, share and सब्सक्राइब दिस चैनल एंड दिस वीडियो लिस्ट. तब तक के लिए बाय बाय, मिलते हैं नेक्स्ट वीडियो में. टेक केयर, लव यू ऑल.